Hi, everyone. Welcome to the SenseThink Acts podcast. I'm the host, Audrow Nash, and in this episode, I interview Adrian Macneil, co-founder and CEO of Foxglove. Foxglove makes Foxglove Studio, which is an open-source visualization and debugging tool for robotics. In this interview, Adrian and I talk about the origin of Foxglove, Foxglove's business model, web technologies and robotics, the timeline for autonomous cars, and Adrian gives advice for those interested in getting more involved in robotics. I really enjoyed talking to Adrian. He has an interesting perspective on technology and seems to be involved in interesting technologies right as they're coming up. For example, he was an early employee at Coinbase and Cruise. As always, a big thank you to our founding sponsor, Open Robotics, and I hope you enjoy. Hi, Adrian. Would you introduce yourself?
Hi, I'm Adrian Macneil, founder and CEO at Foxglove.
Now, tell me a bit about Foxglove, what it does and what problem it's solving, and then I'd love to get into the backstory of it after.
Yeah, definitely. So Foxglove is a developer tools company for robotics. We have our main product right now is an open source visualization platform for robotics, and it's browser-based, cross-platform. We can allow you to really dive into your robotics data, understand any of your sensor data you're planning, visualize things like point clouds, images, overlays, markers, bounding boxes, plots, and drill into kind of raw messages.
And you interface tightly with the robot operating system or ROS ecosystem, correct?
Right. Yeah. Correct. So we work very well with ROS. We're not strictly limited to ROS, although that's definitely our best supported platform right now. We do allow you to connect other types of data sources. Like, for example, we can connect just to a Velodyne LiDAR and talk directly to that sensor and visualize data coming off the sensor. But when you're in a ROS environment, we can obviously make a connection to ROS, and then we have a lot of custom visualizations that help you understand ROS messages like point clouds and images and other things like that.
How does it compare to existing ROS tools like RViz or ROS Visualizer or visualization?
So we have, I would say the biggest difference is that it's cross-platform and using a web-based stack. That was something, we can get into the origin a little bit, but that was something that was kind of a key underpinning of building this technology is that we wanted to work with a browser-based stack, which means that it can run cross-platform. We actually have desktop apps that you can install on your computer that run on Mac, Windows, and Linux equally well, and then you can also access it in the browser. So that that makes it like very easy to just jump into an environment and start debugging. It also kind of unlocks something that I think is important to me, is breaking robotics development out of being stuck with like Linux desktops. And Linux is great, but a lot of robotics development now is the software that you're developing is like very tied to the platform that you're developing on. And if you're using ROS version X, ROS Galactic, you need to be using Ubuntu 20.04, and that's the only choice you have. You're pretty much stuck with that for your development and all of your development tools.
Well, it does work. So Galactic and many of the other ROS2 distributions also work on Windows. Not very well. I think Tier 3 support for Mac, this kind of thing. But
it's getting there. I did see. Yeah, you're right.
But this was definitely
Windows
true for ROS1. Which was kind of the origin of, like, Foxglove was for ROS1 or WebViz at this time.
Yeah, we support both ROS1 and ROS2, But, for sure, Windows support is out there, although, most of the people I've seen doing ROS development on Windows are using the Windows subsystem for Linux, so they're actually still running, the actual Linux version.
Oh, that's funny.
And then Mac, actually, Mac came out. I think ROS2 initially came out and said we're going to support Mac.
It was a lot of work.
It was a lot of work, and I think no one kind of stepped up to volunteer. So the actual code that you're writing being Linux only is fine, right? What we want to break out of is the developer tools. So there's no reason that you can't be on a Mac developing inside a Docker container. But for your actual tools that are like visualizing things, it's those graphical tools are going to be easier if you can just connect to them from a browser or fire up a native application.
Definitely. And what's the big win, or what are some of the big wins doing it browser based as opposed to like Qt or something, which is what Arviz uses?
Yeah. And I think I should jump into some of the other things too. I'll talk to the browser-based thing, and then also some of the other things that kind of differentiate us with Arviz and RQT and things. Browser-based, I think, there's a few points there. One is that it's inherently cross-platform. The browser is a really great environment where, as long as you fire up your browser and go to a website, you can pretty much expect the same experience regardless of what platform you're on. That makes it really good as you're scaling a robotics team. If you start out with just one or two people, or you're working on a project, it's fine if you've got a pretty custom environment set up on your computer. But as you scale up that team, you want people to just be able to, onboard, start working on the code base. Being able to like visit a URL and look at things directly is really great. And then another point there is that it makes it really easy for you to access remote data as well, right? So we can, get into talking about data storage a little bit as well, but a lot of the times, the state of the art in robotics today, a lot of people are just storing, huge 100 gig bag files on their computer and then opening that up and trying to debug it.
And that's ROS bag.
You want to share this with your friend.
Which in ROS 2, it's an SQLite database, right? And I forget what it is in ROS 1.
It's just a custom format. Bag file format is just basically your ROS messages.
But having a big monolithic data storage, basically. Massive. Yeah.
And so these can get really huge if you're dealing with multiple cameras, especially if you start getting into LiDARs and point clouds and radars and other sensors. Plus, you're also recording all of the other messages that ROS is sending back and forth. And so, a lot of people are working with these files locally, but sharing that among team members is really challenging. It's, a case of like either just get someone to wheel their chair over and have a look at your desk, or you can't just like share a link in Slack and have someone else click on that and immediately start looking at it. So that's where we kind of see the browser is really unlocking these workflows where you can just click on data.
And is that talking about having data storage happening in the browser?
Yeah. So not
always.
I mean, the data storage happening on a server, I guess, not in the browser.
For sure.
Yeah. But once you get to having your data stored in a centralized location, and the browser can just easily be streaming that, it just makes the whole end-to-end experience really, really compelling.
Let's see. So I feel like this is a good time to get into the origin story of Foxglove. So can you tell me where it started?
Yeah, sure. So I spent the last 5 years prior to this at Cruise building self-driving cars, and I led basically all of the developer tools and infrastructure there. So when I joined, it was a very small company, maybe 50 people or so. Over that period, we grew into the sort of 1,000 plus range. I think it was around 1,700 when I left.
Wow.
Over that time, the engineering team grew right from 20 people to well over 1,000. And so, they started as, I'm sure a lot of robotics companies do. It was a ROS stack originally on ROS 1. And you have a bunch of people just, contributing code, building features, testing things out. But as you scale that into hundreds and 1,000 plus engineers, you really need to start getting a lot more disciplined around your developer productivity. What tools are you making available to people? What are the workflows that you encourage people to do? The less you standardize things, I guess, the more pain you're in for as you start getting into 1,000 plus engineers contributing to a project.
Yeah. And so Cruise had an internal effort to make something for visualization rather than using the standard ROS1 Arviz or RQT graph or RQT anything? Yeah,
for sure. It started out as Arviz and RQT. As I mentioned, they started out on a ROS1 platform. Parts of ROS definitely got kind of switched out over time and replaced with in-house things. But in the early days, everyone was just using, the standard tools like Arviz. And the project that we kicked off with visualization there, I think we started back in about 2017. It came out of a hackathon, actually. It was not sort of a top-down approach of, this is something we think we need to invest in. It was just something that some engineers really felt needed to exist and really felt would kind of streamline the workflow. So yeah, that was kind of the origin of WebViz, which some people may be familiar with. They presented WebViz at ROSCON in 2019, I think, and it was eventually open sourced in 2019. But back in 2017, it really just started as some engineers on the team feeling that we could do better on a couple of respects. One is bringing these tools to the web, where it's a lot easier for people to contribute to. It's a lot easier to find engineers that can do front end things.
Why is it easier to contribute to it, or easier for people? Why is web easier for people to contribute to?
Yeah, I mean, I guess that could be a bit of a loaded statement, because obviously, if you're familiar with C++ development and Qt development, then it's going to be a lot harder for you personally to contribute to. But on a scale of larger commercial engineering teams, it's on average a lot easier to find front-end JavaScript engineers who can build web applications. There's just a much larger pool of people that you can draw from there.
What would you guess the order is? Is it like there's 10 times more people that are familiar with JavaScript than C++? Or, I mean, just ballpark for these kinds of jobs?
Yeah.
You think it's 10, or like just order of
magnitude?
magnitude?
Probably in the Bay Area, that wouldn't be far off.
Yeah.
I haven't seen any numbers specifically on it, but anecdotally, going out to hire a front-end engineer versus a C++ engineer who has
Qt experience,
development experience, Qt experience and things like that. Like, for sure, there's a lot of really talented C++ engineers out there, but not so much on the visualization side. There's a lot of people that have done game development and things like that, but just much easier especially once you're a company. You start building a lot of internal tools. Usually a lot of the internal tools are web-based. I don't want to push on being easy to contribute to as like the main thing, but it's that combined with the fact that anyone at the company can just hit a URL and access it. You don't need to worry about like deploying this app across your team. And also, there was something that was important to us was being able to like unify these various tools into one interface. So
you mean RViz and RQT?
Like, yeah, exactly.
And so RViz, can you speak to what each does just a little bit?
Yeah. So RViz is primarily a 3D based visualization tool. So you can go in and you can open up some data and you can look at where your model is sitting in the world, and you can see sensor data, and you can see 3D markers, 3D bounding boxes, and things like that. You can see things like your transforms, like the shape of your robot, and where your robot is relative to something that it's trying to act on.
And if I understand correctly, it's not a 3D simulator, it's more just 3D visualization. There's no physics engine associated with it.
Right, exactly. So it's purely taking
purely informational.
Taking data from your robot and then just showing you, how your robot is thinking in the world is kind of an insight into your robot. And then you have, RQT is sort of a collection of tools that you can open as standalone windows, or you can kind of open them in a sort of attached panel configuration. And it comes with a handful of other tools which can give you things like reading diagnostics from your robot, reading direct messages from your robot, reading plots from your robot, or not reading plots, but displaying plots based on data from your robot. And then, you start seeing that there's other tools, more recently that have come out, like Plot Juggler and things, which, are separate again. And so, that was kind of one of our insights, I guess, at Cruise.
To combine them?
In one of my early days there, I have a vivid memory of attending. So we had Friday demos basically every week, and people could jump up and kind of just show something cool that they'd built that week. And someone from the QA team jumped up and demoed the script that they've written that would basically take a bag file and then open it, start ROS in the background, and then launch about like 12 different windows on your screen and rearrange them into position so that you'd be ready to start debugging. And I kind of looked at that and I was like, and they got a standing ovation for that, right? Because it was such a massive time saver compared to you like manually going through that process and, taking a bag file and launching ROS and then opening these various windows. And I remember that so vividly because it's like seeing the pain of how difficult it is just to get to the point where you're actually getting your work done. It's like this is just like admin before you actually get to the
20 minutes of work or something before you can start working.
Right, and actually, and that's actually sort of another point of differentiation we took is that the tools like others they're very coupled with ROS, so you have to have ROS. You run ROS in the background. You start your ROS stack, and then you start others, and others will talk to ROS, and it'll show you kind of exactly what's happening. And if you want to play back a bag file, play back a recording that you have, then you need to play that back into ROS, and then kind of you'll see it in others as like a byproduct of that.
Yeah. So it's going over the ROS network, basically.
Right. Everything's kind of going over the ROS network, and again, when you start thinking about different workflows across the company, you have QA engineers who maybe are assigned to have a look at...
Right? So they want to make sure the software is up to good quality and we're doing things well? Okay.
Right, exactly. And if they're taking, let's say there's an incident where, something bad happened on the road, right? We pulled out too soon or we got too close to a cyclist or we, whatever we did. And you've been assigned to triage, an engineer has been assigned to kind of triage this and figure out maybe not like what is the root cause just yet, but where do we think the likely root cause is? You want to be able to just like open that kind of incident directly and start looking at it.
You're saying the data captured from the incident?
Yeah.
The associated ROS bag file or... Okay.
Right. But you want to, like, what you actually want to do is get into visualizing that incident as quickly as possible. And you don't, the fact that there's steps like downloading a bag file,
which is huge, often
checking out the code base,
which is huge, probably. So it probably takes a while to
downloading like 100 gigabyte bag
someone
file.
had to upload that, and upload speeds are often slow. Or you get it from a thumb drive or something. Okay.
Yeah, I tell you all about network. Yeah, so it's just a process, right? You kind of take that bag file and you bring it down to your computer, and then you open up, you check out the code base, and you go back to the version of the code base that you had last week that was actually running on, and then you launch ROS, and then you launch others, and like now you're looking at the data. And we just wanted to simplify the whole process, so it's like you click on the link, and then you're looking at it immediately.
Yeah, that is way easier. Where you can just open it. And so and then this gets into the cross-platform and everything because they could be on any computer and they don't need to spin up they don't need to have ROS installed and they don't need to have ROS bag installed. And they just run it.
Have a Chromebook or something and just, immediately jump into things.
Gotcha. Okay. So then I see the motivation for this quite clearly. So you were at Cruise and you were working on WebViz. And you had this experience where someone automated some of the setup that they might go through when trying to do some debugging. And that was like an aha moment for you. And then is that how WebViz started?
Yeah. And, to clarify, I guess I was the director of engineering there, so I didn't contribute, much or anything to the WebViz code itself. The team was under me, but all of the talented engineers were did the work, not me. But I very much agreed with the vision of what they were trying to achieve there, and I think the team that was working on that, there were some really talented engineers. They kind of made a proof of concept, like I said, at a hackathon. They went around, a handful of different teams, and kind of went team by team and said, hey, what problems are you having with your tools? How can we solve them with your visualization? And just incorporated all of the various workflows that were happening across the company into this one tool. And so, over that period of a year or so, it just became kind of an indispensable tool that everyone was using at the company. And that really just opened my eyes up to how much of a productivity boost a good quality visualization tool could be. And that's what ultimately led us to open sourcing it.
Gotcha. And so you open sourced WebViz, and then now you are with Foxglove. Can you tell me a bit about that transition?
Yeah, for sure. So we open sourced WebViz at Cruise in around 2019. The goal there was to give back to the community, and to also just to put some of our code out there as engineers working on projects at companies. Quite often you want to just put anything that's not sort of like
tied
critical
to
IP to the company.
Yeah,
critical company secrets. It's always nice to be able to publish things, and we published a lot of open source code at Cruise around even just unrelated things like how we're managing our Kubernetes infrastructure and things like that. But we put WebViz out there, and it was available for the community to use. And they presented it at ROSCON 2019, I think, and picked up a bit of steam. Certainly, people were out there using it. But I guess here's where I would draw a differentiation between not all open source code is created equal. I guess there's a difference between kind of code that is public versus actual communities that are being built. And I don't fault Cruise for this in any way. I think Cruise is absolutely making the right decisions for their own prioritization and things. But I was like part of these decision making. But Cruise doesn't have time to build features in WebViz that are not useful to Cruise. For example, they have the project out there, but like no one is building ROS2 support into WebViz, or no one is building
because their stack is ROS1. Or at least it was.
Right, exactly. And their stack now, their stack's kind of, heading off in a different direction entirely. So, it's the code was out there and it was available for people to use, but there was never a kind of a pretense that Cruise wanted to sort of invest heavily in building a community and adding features that were like not useful to them at all.
Yeah.
And like I say, this is, absolutely the right decision. If the purpose of your company is get a self-driving car going in San Francisco, the purpose of the company is not build unrelated kind of open source communities and invest heavily in that. Sometimes it happens, if you're a company the size of Facebook and you
with like React
you go out
or something,
you build something like React, exactly. Like, sure, you have hundreds of thousands of employees and you can spare a small team of 30 to work on XYZ thing, but
it's crazy. It's really that small of a team.
Yeah.
That makes sense, but I didn't know.
I don't know. It could, or
something
just,
like that.
Just guessing.
Yeah,
but it's when you're a sufficiently large company, you can kind of afford to make those bets. But for the majority of companies out there, when they're open sourcing code, it's usually sort of here's some code that we wrote, use it if you like it. But
we're not supporting it.
The
We're not
internal
adding
team
to
is
it.
still focused on like internal needs.
Yep, makes sense.
Yeah, so that's what ultimately led to Foxglove. We had a lot of chats with the WebViz team and with Cruise leadership, and several of the WebViz team work at Foxglove now. But we wanted to make a clean break. I guess we another bit of context is that WebViz, as it exists today, is pretty tightly coupled with a lot of internal Cruise systems. So the open source version of WebViz is only about half of the code, and WebViz is actually open source, right? And the rest of it is special custom source that exists inside a Cruise. And those two are quite tightly intertwined. It's not sort of super easy for us as founding Foxglove. It's not super easy for us to go and kind of contribute back to that project without having access to all of the closed source things.
Yep, makes sense.
So we made the decision when we founded Foxglove at the start of this year that we wanted to kind of carry on WebViz in spirit. And we forked the code base originally, which means we took that code base and we're basically saying, WebViz is here. It's the open source version of WebViz is not really undergoing a lot of significant change right now. Most of the team that still works on that at Cruise is primarily focused on Cruise specific additions that are not open source.
Yep.
But we said we're gonna just we want to continue this in spirit, but it's going to become a different product over time, and we don't want to sort of create kind of confusion there. We just want to say, hey, we're building Foxglove. We're using some of the stuff that was done in the past. We're incorporating a whole bunch of our own ideas, but we're not kind of being held back by
what's of company interest.
Technical, exactly, like company interest or just like, technical limitations around how projects are kind of tied to internal code.
Yep. And how did you decide to form a company around this as opposed to any of the other things that you could have done? Like it could have just been a side project, or like how did you decide to jump off and run Foxglove?
Yeah, I guess, that's a really good question. I believe very strongly in the future of robotics. I think, there's an enormous industry out there or enormous opportunity out there for robotics to just completely change what our economy looks like, what society looks like. I think people are massively underestimating how much robotics is going to impact the next 10 or 20 years of kind of human life.
Wow.
And I also really believe that high quality, I love engineering productivity, development productivity. I believe that high quality tools can help people focus on doing what they do best. And I've seen at Cruise and other companies, I've seen really talented engineers who are like deep domain experts struggle and spend 80% of their time fighting with something that they don't properly understand because it's not their expertise. And likewise, I guess that's where I always felt that I and others can kind of contribute because, I'm not a kind of, controls PhD or machine learning PhD or anything. Like I don't claim to be
a super expert at something.
But right. But I can tell you how like build systems work and data works and systems plug together and visualization and how these kind of things work. Mm-hmm. And I really believe that kind of, good quality tooling means that domain experts can all focus on kind of their area of expertise.
Gotcha. So you're basically making it easier for people to work on what they are good at, through good tooling.
Right, exactly.
And
so that, I guess, tying it back to your question was, how did that lead to founding Foxglove? Was that with Foxglove, we wanted to, visualization is where we're starting, but the ultimate goal of Foxglove is to make robotics development easier, right? We want to be able to help roboticists focus on their domain problems, focus on shipping products and not worry about, how they're thinking about their tools and their data and their development workflow and all of these things. So the visualization piece is our starting point because I believe that there's just, such big low-hanging fruit there. It's something that we saw be so impactful at Cruise, but, we have kind of a roadmap of other areas that we also really think we can help in.
Awesome. I'm interested to talk about that. But first, you also had a lot of, several people go from Cruise to working at Foxglove with you. Would you tell me a bit about that?
Yeah, so my co-founder and I both, so my co-founder Roman, he's our CTO, we had worked together for a long time. We actually worked together before Cruise. We worked together at Cruise. Before Cruise, we worked together at Coinbase, and that was where we met. So I was an early engineering hire and the first head of engineering at Coinbase back in the early days. And we met there. We worked together for a long time. He was actually the one that introduced me to Cruise and convinced me to come there. And then, so, we really wanted to do something together around robotics developer tools. We got chatting to a few folks. Several of our team members have come from Cruise. Mostly not directly. I guess, like I said, it was sort of 5 years since or more now since I started at Cruise. So Roman and, several of the other folks on our team had come from, had been at Cruise for, 2-3 years and then had gone on to other companies, robotics and things like this. And then, we kind of just reconnected with a bunch of people in our network and to see who would be interested.
Sorry, Siri popped up. What would you say for the last 10 seconds?
Yeah, just that we, a lot of those people had been at Cruise, and then had gone on to work at other companies, and we just reconnected with some folks in our network to see who was interested in doing something around this.
And Now, you said you strongly believe in the future of robotics. Would you just tell me a bit more about that? Like, what is making you so optimistic about the future of robotics?
Yeah, I mean, it's inevitable, right? You see, um, I mean, and partly maybe this comes from having worked at Cruise and seen what is possible. I think, a lot of people haven't really had that glimpse into what is possible, but when you sit in a car that's driving itself around a busy intersection with, potentially hundreds of people walking around it and cyclists and cars, and, you see a car that can, I mean, I was, 6, 7 years ago, very skeptical about self-driving cars. But having gone and seen and sit in those cars and seen the progress it's made and seen things that you hear people, well, you talk to people on the street that have not worked in the industry, and they say, well, I don't think self-driving cars are possible, because sometimes you just need to be able to understand, what is the other human doing. And then you see teams just plug away at problems like, a four-way stop sign. Is very common in America, where cars have to basically take turns at giving way to each other, and especially in San Francisco, you have to be quite assertive at a four-way stop sign. You pull up to a stop sign, and technically it's your right of way if you got there first and someone else got there half a second later. But if you don't start pulling out into that intersection, the other car is gonna go very quickly, right?
Yep.
And so you look at these problems, and you start thinking about people signaling and things like that. But you see teams like chip away at these problems and get to a point where they've tuned the car where as the car's turns coming up, it has like a very human-like behavior where it pulls forward slightly to kind of indicate its intention that it's going to go, and that actually causes the other cars not to pull out, because they can kind of see your intention that you're planning on going. And these things. They sound like very human behaviors, but you can actually just really get down into kind of encoding that in machine learning models, or even hard coded logic in some cases, where the car is like exhibiting very human like behavior. So it's really interesting. You kind of see that evolve, and then you look around the world and you just see how many things are done, how many sort of tasks or jobs are done by humans today that are both like very uninteresting, very repetitive, could be done better, more reliably, cheaper by machines. And the kicker is that they're way easier than driving around San Francisco.
Yeah.
So there's this great quote that, the future is here. It's just not evenly distributed,
Yep.
right? It's just inevitable to me that the march of progress is going to, if you took all of the technology that was currently being developed in self-driving cars and applied it to, warehouses, logistics, manufacturing, agriculture, shipping, like there's, food prep, food production. There's so many areas where all of these environments are much more constrained than driving around a city. And if you took 1,000 engineers and applied it to that, there's no doubt that those would be solved, very quickly. The thing is, right now, there's not that. I guess economic investment is not there to put 1,000 engineers on a problem about a self-driving forklift or something. We're certainly getting there, but it's not at that scale yet. But you get this kind of flywheel effect where, as more people start trying to solve those problems, better tools come along, better frameworks come along, better libraries come along, there's more off the shelf that people can use, the flywheel starts spinning, and then teams of 10 engineers can all of a sudden have the output of what took 1,000, a decade earlier. So, that's what makes me so interested and optimistic about the future of robotics. It's just that, it's going to have a massive impact. And I think that I don't think it's really kind of reached the public consciousness yet. Everyone's talking about blockchains and AI, but, I think like robotics is kind of the defining application of AI maybe. And,
cool.
And people haven't really sort of grasped that yet, I think.
Mm-hmm. So you mentioned several domains, agriculture, manufacturing, etc. Are there any specific areas within those, or any specific problems that you think are particularly interesting and ripe to be solved by robotics?
Yeah. I've seen some very interesting stuff happening. In warehouses like Fetch Robotics are doing really interesting stuff there. Obviously, being on your podcast earlier, and seeing I think all of these things where you have self-driving forklifts, for example, a lot of the stuff. I mean, I've coming into the agriculture industry, for example, I grew up in New Zealand in a kind of very in a rural region that does a lot of fruit growing and picking, and I had jobs in high school where I was packing kiwis into boxes, and I can tell you all sorts of things. I've done pruning, and I've done like a number of these tasks that kind of happen in the agriculture industry, and some of the tasks that you do are like sit here and watch these fruit roll by and grab the ones that have blemishes and put them on, grade them into like A, B, or C, and grab the ones that have blemishes and put them, onto this other conveyor belt. And it's just not a sensible task for a human to be doing in this day and age, right? I mean, maybe it was, 15 years ago, something when I was doing it, but like, computers with computer vision and like manipulation arms and things can just do a much better job of this now. They're going to be far more reliable. They can do it at a higher pace. And like, guess what? That wasn't a fun job for anyone. I certainly didn't enjoy it. Like there's much like more productive things that us humans can be kind of putting our time and energy towards than watching fruit roll by and picking out the ones that like look strange.
Gotcha. And one other thing that kind of caught my ear was you saying putting 1,000 engineers towards the problem. Can you just talk a bit about that? It's an interesting idea to me, and it's very different than, say, like a startup-y thing where you have the 10 engineers that you were mentioning and building a product from there, or just a couple.
Yeah. I guess I would look at it from a perspective of what, in 1999, right? So you wanted to start a startup in 1999, and you're going to build some web, you're going to build Amazon or something. I guess they were a little bit earlier. Okay, you're going to build Amazon in 97 or something.
Okay.
You're going out and you're like, you need some people to write code, but guess what? You also need some people to go and buy some servers and rack some servers up, and you need, just like multiplies, you need people doing especially as the website starts getting traction, you're building everything from scratch, right? So, when you say there's 1,000 engineers working on a problem, it's not that they're all kind of in there super productive writing the key kind of code day to day. It's that you have to build kind of all of the infrastructure of the pyramid underneath you as well, because there's nothing that you can
it doesn't
just
exist.
grab off the shelf.
Whereas now
right.
you
and
can,
so,
if you're building PayPal or something, or Amazon, you can use React or some other framework that does a lot of the lifting for you.
Right. If you're doing this 20 years ago, you're building Google or Facebook or Amazon or eBay or any of these things. You're building everything from scratch. You're not, you're not just grabbing like a web framework like React or Ruby on Rails even or something. You're writing all of the web from scratch. You're writing all of the deployment from scratch. You're buying hardware. You're racking hardware. You're worrying about like network connections. You're making deals with ISPs so that you can like, get enough bandwidth for your servers. Like,
it's crazy.
I mean, it sounds crazy, right? But like that's how all of these companies got started, and that's where we are in the robotics industry today, right? We're at this place where if you want to build you build a self-driving car company, I mean, 90% of the engineering effort is not going to the core kind of, the core kind of like algorithms and models that are being developed on the car. It's all of the stuff around that, everything that
the supporting infrastructure
is not available off the shelf today. Yeah. So, if you took that, one approach is kind of brute force, which is like you take those 1,000 engineers and say, hey, we're pivoting to like self-driving forklifts now, go. Sure, like maybe it's an easier problem and all that talent could get it done, but I think the more kind of scalable approach over time is that better and better quality tooling comes out, and in the web industry that was AWS coming out, that was Heroku coming out, that was Datadog and Splunk and New Relic and Sumo Logic, and all of these kind of startups were founded in the latter half of 2010, latter half of the 2000s, sorry, where by 2015, you want to go and start a web startup, you just kind of like slap a few things together and two people or one person and you have a company.
Yep.
I think robotics needs to get there. Obviously, it's never going to be as easy as building a website. You have like hardware in the real world to deal with. but it could come a long way from where it is today in terms of like having just reusable components that you can grab off the shelf, glue together, and have a company.
Mm-hmm. So in all of this building infrastructure, in your mind, where does open source fit?
Yeah, that's a really good question. Open source is both like, I guess, very important. It's contributed a lot, and we deeply believe in open source. I think the open source industry has matured a lot over the last kind of 5 or 10 years, especially even the last 5 years, in what business models work and what business models don't. You've had some of these things where you see like Elasticsearch, MongoDB. A lot of these companies have kind of gone through a little bit of a crisis where they've said, hey, we give our thing away for free. And then someone like Amazon comes along and takes that thing that you were giving away for free and starts reselling it. And they've kind of like sucked the air out of the fact that you actually still need to pay employees. So I think, we're at an advantage that, sitting here in 2021, there's a lot of evidence of what models work in open source and what models don't. I think the fact remains that open source is a really good way to get products out there and make them easy and free for people to play with. It's a really good way to build a community around projects. It's also, frankly, a lot easier to work with, as a consumer of open source, even if you're paying for support or services around something. If you get some, you're working with a tool. As a developer, you're working with a tool and then it's not quite working for you, or you find a bug, or you need a feature. It's so much easier if you can just like look at the code and fix the bug or build the feature.
Rather than a binary.
Kind of be stuck in this you're not stuck in this like crazy loop where you've got to like go to their support and then it needs to be, like turned into a ticket and goes to a PM somewhere and they farm it out to a team and you wait like 2 months when you could have just changed a bit of code yourself.
Yeah.
So, open source is really important. I think we strive to, we can talk a little bit about, how we're thinking and where we're drawing that line, but I think it's important to, try and open source as much as you can and make that available to the community and build a community around it. But also, you need to be realistic about the fact that you need to be able to pay your employees and you need to kind of fund the development and the other things that come around it. So it's important to have kind of clear delineation there, I guess.
Yeah. And so now, natural segue, what's your business model at Cruise? How are you kind of balancing open source and paying your employees and things?
Yeah, at Foxglove.
Or Foxglove, yes.
Yeah, exactly. So we, in keeping with that, I think the model, one open source model, and actually, I think I was just listening to your podcast with Dave Coleman at Picnic, and I think him and I probably share some similar views on this. I think I don't like the open source model where you kind of have an open source version and then you have kind of a better version that you have to pay for, which is just, more features around that. I think that frustrates people and it, kind of feels like you're just kind of keeping the crown jewels for yourself. I think, much better models that we've seen around open source. There's kind of two related models that work quite well. One is just that you have an open source product that people can run themselves, and then you just sell basically hosting of that thing. And so, that's where you see a lot of companies kind of doing this today. That's, what like Elasticsearch and MongoDB and some of these people do. You also see it with like Next.js and Vercel. They kind of offer like a paired hosting. So that's a front end framework, web development framework, and a web hosting company, and kind of they sponsor the thing. So that's one option is, you build a thing which is completely free and then you offer hosting of it. The other option, and where we're going, is you build a thing that's completely free, you get all of the features, but there's kind of add-on services that you need if and I guess more specifically in our case, we give you Foxglove Studio. It's free. It does everything you want. You can run it on your computer. You can run it on the web browser. There's no limitations. If you want our services for collaboration and for kind of like team communication, which we're building around that, then those are things that you need to log in for, and those are ultimately going to be paid features. So we actually, I guess, sort of pre-announcing this a little bit, we'll be coming out with more in a couple of weeks, but we have some features in Foxglove where today you can kind of have these layouts that you have personally that live on your computer. You can set up different layouts that you might use for different tasks where you're debugging, a particular type of event. And we are coming out very soon with a couple of things. One is the ability to kind of share these layouts among team members. So being able to actually log in, starting to get into this world of where we're sharing views among your team and making it easier for people to collaborate over robotics data. And then the other thing that we're building, which will be a kind of hosted service that you can work with, is actually that data storage element. So how can we be the central repository for your data so that as I said earlier on, so that you can just click on a link and immediately start looking at it without having to go through that whole rigmarole of downloading 100 gig bag file to your computer and sharing it to your friend on a hard drive and running any of these things locally. You can just have a kind of central repository for your data, click on a link, and immediately jump into it.
Mm-hmm. Now I'm struck by so you were saying you and Dave are sharing. Dave Coleman from Move It or Picnic are kind of sharing a mind for these things. I'm struck by you guys both calling your service with something Studio. So your Foxglove Studio and he's Move It Studio, their new release. Why did you pick the name Studio? What's there?
Yeah. And I mean, since creating Foxglove Studio, I think maybe it's just I've started seeing it everywhere. I think we're not the only two companies. I've seen sort of 4 or 5 other companies with XYZ company name and then XYZ Studio.
And it's the paid version of whatever it is.
I mean, I think it's intended to be just a product that you can jump into and you can see what's happening. I guess we wanted to separate that product slightly from the company name because as I kind of alluded to, we're planning to bring out some of these other services and things. So we needed something to
differentiate.
Yeah, exactly. This is our kind of visualization tool that you can see and open, and probably Picnic maybe and Move It felt the same way.
Yeah.
But yeah, I guess and it starts becoming a little bit of a mouthful if you have another studio releases like an easy word that makes sense. But if you come up with maybe you already have a company name and then you throw something else rather long-winded on the end of it for your product name, you get these things like HashiCorp Terraform, and you're like,
what is that? Yeah.
Yeah, what am I?
And speaking of what's in a name, although it's a bit of a digression, and I'd like to get back to more of Foxglove Studio, but how did you come up with the name Foxglove?
Yeah. This is a question I get a few times. So I have, my philosophy on naming is that I think that if I say the name to you, you should be able to write it down. And if I see it written down, or if you see it written down, you should know how to say it. And I get kind of frustrated with some of these company names where, they're either just insane, not even company, just project names. I mean, you have Kubernetes, for example. Everyone goes around saying Kubernetes like it's an easy thing to say.
Yeah, but, it's like some StarCraft thing or something. Or
right, yeah.
Star Trek thing.
I think it's a Greek god reference or something. Maybe.
Yeah, well, I mean, it just sounds like some futuristic device to me.
Yeah. It's so I have this predisposition towards names that are easy to say and easy to spell and easy to read. But of course, most of those are taken. So I spent a long time with this kind of short list of names that I was going through, and I was last year just traveling around New Zealand, and I was doing a bit of a road trip with my wife and child, and there's kind of foxglove flowers were all over the side of the road.
Oh.
And I did this. So this is a foxglove in case this flower I have in the background. So it was
cool.
Yeah, just a word, and I thought that's a cool word. And it wasn't already taken by a startup. So there you have it. There's no robotics reference. I'm sorry.
I didn't know. I just had no idea where it came from. So it's a flower in the hills of New Zealand somewhere.
Yeah.
That sounds lovely.
Yeah.
Okay. So if I understand correctly, so Foxglove Studio, so you have all of Foxglove where you can visualize the data you see, and it's for live playing of ROS2 data and also playing from a bag file, correct?
Playback, exactly. So you can connect to a live system, or you can just drag a bag file in and immediately start looking at that bag file. You don't need ROS installed or anything. If you have a bag file, you can just open it.
And then the studio, what are the kind of killer features that you're adding with this? So it's layout support, so you can save a layout. Eventually, you can share a layout, and it's data storage coming soon.
Yeah, these are the paid features that we're building around it, basically. So anything that involves kind of collaborating on your robotics data, where you have multiple team members. Again, maybe you have a team of 5, maybe you have a team of 20, maybe you have a team of 100. But the larger your team grows, the more important it is that you can collaborate over that data. And this is, I think, people naturally understand this because, normally if you have data stored in Datadog or Splunk or Google Analytics or things, it's kind of second nature that you can just look around a website and then you copy a link. If you want to send something to your friend, you just copy a link and paste it in Slack and they can start looking at it. And so, this kind of collaboration around robotics data, I think, is something that just doesn't exist in the industry today. If the kind of, it's very much a single focus on just, like, here is my personal workflow. I have some data locally on my computer. I have a bunch of tools locally on my computer. And if my friend wants to look at it, then they're kind of out of luck.
Or you have to write a README up, and then they can try to reproduce what you do.
Right. Exactly.
And it's 10 steps or more.
Go here, get this file, open this, show these topics. Kind of, it's a very sort of arduous process.
Mm-hmm. Gotcha. Now, I want to segue into talking about the web and connecting it to robotics in some capacity. Like, I'm very excited about this, but would you speak on it? What you think the potential is there, why the web will be good. You mentioned it a bit before, and that there's a lot of people that are knowledgeable of how to do web programming. But anything else?
I think, this is something that a lot of companies are independently coming to this conclusion. The web is kind of the main platform that anything visual is built on these days. And, that can mean developer tools like us, where you're kind of diving into specific instances and incidents of your robot. It can mean kind of fleet operations tooling, where you have companies like Formant.io and Freedom Robotics and Orbit, where you have a web-based interface where you can see your whole fleet of robots and see what's going on with any of them. It can also mean things like teleoperations and remote assistance, where you need your robot to kind of call out and get human support or human eyes on things. It can even mean, and web-based labeling tools, for example, where people are annotating data to use for machine learning training. Those tools are, again, primarily web-based. And it's just because you have this platform where you can build, visual interfaces, and they're inherently plugged into remote data stores. It's easy to save, collaborate. It's kind of, a similar transition from having Microsoft Word installed on your computer and moving to Google Docs, right? It's just, now you're moving to something that is inherently collaborative. And so, when we talk about like the web and robots, I think we're not really advocating that your robot is written in JavaScript or something like that, although it's perfectly possible if you want to go that route. But the robot is the robot. Usually it's running ROS or something similar. It's written in Python or C++ or something similar. But it needs to kind of communicate with that outside world. And so that means often you use web-based technologies for connecting from the robot to services. For example, like WebSockets are a really good way of a robot communicating with a server, or a browser communicating with a server. You also have technologies like WebRTC, which is a way for, that's probably how our video is getting to each other right now. It's kind of a way of streaming videos and things like that across the internet. And so you have a lot of these kind of web-based technologies, and they play really well with robots. They're really good for, communicating with fleets. They're really good with communicating, even to local devices. And it's really good for building interfaces where, you don't have to worry about which browser or platform or things you're running. You can just kind of, you can just open it up and it works.
And do you think, can you talk a little bit more about the benefit of making it so that a lot of robotics related things are made in a way that, like getting us a bigger pool of programmers to work on robotics problems through using web technologies?
I think, that is something that always I found interesting at Cruise, actually, was as we were hiring candidates vastly underestimated the need for robotics experience to work, or a self-driving experience to work at a self-driving car company. And kind of, when we're talking about the thing with the 1,000 engineers and how, 80% of them are working on, the pyramid that kind of supports the actual key algorithm development. We needed to hire a lot of people at Cruise that were just experts in infrastructure and data processing and data management and web development, front end development, JavaScript engineers, and we didn't need any of those people to have a PhD in machine learning or robotics or anything like that. But there's kind of this perception out there that if I'm not a robotics developer, I can't go and work at a self-driving car company. But like I said, I think there's a large number of candidates out there, or just people like engineers out there that work for companies doing all sorts of stuff in Silicon Valley today, and around the world, and a lot of that stuff is much less meaningful. There's a lot of people working in ad tech and things like that could be working on robots, but maybe think that they can't. So I would implore those people to have a look at some of the really awesome stuff that is happening out there, and realize that one of the most exciting things to me about robotics is just how diverse of a space it is, how many different skill sets you need. And, you can come into it and maybe you're experienced in front-end development, or maybe you're experienced in DevOps, and you'll sit down with people who are, like I said, machine learning PhDs or something, but you'll sit down with people who are physicists and people who are working on, hardware, and you'll sit down with electrical engineers, and all of these people need to kind of come together. And, it's really important to bring all of those skill sets together in robotics. And I think, I don't know. I think there's again, a huge opportunity there as more of the, maybe for a long time, robotics has kind of been a little bit off in a corner. A lot of the industry has been building, ad tech and consumer startups and even enterprise startups and a lot of stuff for processing enterprise data, and a lot of things for social media and social networking and things. But robotics has kind of spent a long time in a slightly academic corner of the world, I guess. People have been working on robots for decades at this point, and certainly the last 15 years there's been a lot of really interesting stuff happening, but it hasn't had as much kind of attention, I guess, as the wider startup industry. And I think we're kind of reaching a tipping point now where more and more engineers are coming over who have experience in maybe more traditional software development. Maybe they don't understand the robotics pieces, but they can sit down and pair with the people who really understand control theory or machine learning or planning or things like this, and you put that together, you get some really high quality software.
Gotcha. Very interesting perspective. Do you think that web technology, so we're speaking about often web technologies kind of on the front end, so mostly for visualization or connecting to other things. Do you think it will ever, or are there benefits to doing web technology, so from the back end, so using things like Node.js or Dino or something like this?
I mean there's kind of a truism that everything that can be written in JavaScript will be written in JavaScript at some point. So
I haven't heard that.
There's people out there writing robots in JavaScript, and even the JavaScript ecosystem is not what it was 10 or even 5 years ago, right? It's continually moving, and a lot of these things like TypeScript have come out, which provide a lot more structure around.
I really like TypeScript from the few side projects I've done in it. Seems excellent.
Yeah, exactly. It's really nice. These things are coming out. So, for sure, I think people will use languages like JavaScript and Node.js and things on robots. But equally, you're seeing people branch out into using Rust for robots, for example. And that would arguably be a better fit for a lot of these kind of embedded applications where you're pretty resource constrained. You have to deal with even when you have a very large computer available to you, you're always worrying about energy consumption, battery life, and competing things that are trying to run on it. So I think Rust and Go probably are both potentially quite interesting. things that might end up, picking up a bit of steam on robots. But I wouldn't say that JavaScript or web tech has an inherent advantage for writing kind of the robot code itself. I would say most of the benefit there are things around how you're communicating with backend services, how you're building UIs for people to interact with your robots. Things like ROS Bridge, for example, is it's a WebSocket protocol where you can connect from a ROS system to a web browser, or from a ROS system to a server to a web browser. Our team has been contributing a bunch to the ROS Bridge project lately and getting that up and running with ROS 2, which has been really great for the community. These are really where the web stack plugs in, and the protocols that we're using to communicate with robots, and the kind of interfaces where we can interact with robots.
Mm-hmm. Now, I'd like to talk about you for a little bit. So you were at Coinbase as one of the early employees, then you were an early employee at Cruise, and now you're starting Foxglove.
The earliest.
The earliest, yeah.
Yeah.
So to me, it's kind of, I see it as you're jumping into things when they're very interesting. So you jumped into cryptocurrency. You seemed like you were very early into that, being at Coinbase when they were pretty young. Then self-driving cars, and it basically took off. There was so much interest around it, and Cruise went from 20 to, 2,000 employees or whatever you said. Can you just tell me a bit about your thinking around these things, your experience? I don't know.
Yeah, for sure. I do really enjoy, I guess, futuristic technologies and thinking about the future. Some people maybe, take this a little too far and think about things that are, unachievably far out. And if it's going to take 50 years, then, maybe it's not the best thing to invest your time in today, or maybe someone needs to. But I really like thinking about this kind of, 10 or 20 year horizon and what direction is the world going. And that I actually early in my career I did a lot of things with payments and e-commerce. I actually wrote an entire e-commerce framework and a bunch of payment gateway integrations, and that led me to sort of interest in Bitcoin, I guess, pretty early on. I saw, I just started looking at Bitcoin. Initially thought it was a scam, but then started getting interested in this idea of kind of cross-border payments and permissionless money, and I thought there's a real opportunity for this to become something that is a lot bigger than it is today, and that's something people use in their day-to-day lives. I would say with the Bitcoin space in particular, though, there's a lot of people, and even in the early days, there were a lot of people who were in it for the technology, I guess, who were kind of excited about what the future could bring, and even the kind of technical developments that had happened there. But because it was kind of also a financial instrument, there were a lot of people who were just in it for the money, and that led to quite a sort of hostile community. I actually think maybe crypto has turned a bit of a corner now. You're getting a lot of these kind of things coming out, like NFTs, where people are clearly just having fun with it and not stressing so much about whether they're going to be millionaires or anything. Maybe they still are, but I don't know. The crypto community, there was a lot of, especially in the early days, there was a lot of infighting in the community around block sizes, and it got a little frustrating to me that it was
kind
an
of
interesting
petty
technology
instead of lofty, because it could be interesting, the technology and the implications of it, but people are infighting, trying to get a little more influence or a little better deal for themselves or something like
Right.
this.
It kind of attracted, a few of the, and, different people were in it for different reasons. Some people like the technology. Some people just wanted to get rich. Some people were in it because they think all taxation is theft and that the government should be abolished or something. Yeah. And so you have this kind of strange melting pot of and then Coinbase was right in the middle of that, trying to sell Bitcoin to people who thought that, all tax was theft. But yet had to appease banking regulators who very much thought that they needed, or legally very much did have to understand absolutely everything that's happening about every transaction on the platform. So that was an experience. But I I kind of, as I said, my co-founder sort of introduced me to Cruise. He was at Coinbase, and then he went to Cruise. And I guess I went through the experience that I was just describing earlier, being an engineer, not from a robotics background, but kind of coming into this company. My eyes were opened up to both like opportunities that were possible, but also that it was very obvious that I could actually contribute a lot despite not having that robotics experience, because I found that a lot of the robotics engineers didn't have the experience I had. And it's just, like I say, you have all of these people from different backgrounds come together, and you need that in robotics. You need the hardware engineers, mechanical, electrical engineers. You need the, ML folks. You need the planning controls folks. You need the backend infrastructure. You need the kind of UIs and visualization. It was kind of obvious that this was both something that, was also going to be a big interesting trend. But I felt that there was a lot more focus on kind of substance, I guess, compared to the crypto space, where it was a little bit, a little bit too much hype. So that kind of, led to my interest there. And I think Cruise really opened my eyes to, what was possible in the space. Like I said, I think it's really clear that the robotics industry has been making a ton of progress over the years. It's clear that a lot of these problems, that people have struggled with, actual technical problems in robotics that people have struggled with, are within reach now. They're solvable given enough time and resources, and given better tools, the time and resource kind of needs are going to come down. So, that, like I said, that kind of just continues the trajectory to Foxglove, where I think we can not just help one self-driving car company get off the road, but you look around, you see all of the self-driving car companies are building the same tools, and you say, hey, there's an opportunity here to kind of like reduce duplication, reduce kind of people reinventing wheels, but also we can look at all these other robotics companies that don't have anywhere near that level of resources, and they all need it too. So, there's just opportunities here for us to make everyone's life easier.
Mm-hmm. That's great. I'd be remiss if I didn't ask, what do you think the timeline is for autonomous cars?
That's the money question.
I mean, even like order, like next couple years, next tens of years.
Yeah. I mean, they're here, right? So it's a question of what can autonomous cars achieve, and autonomous, like level 4 autonomous cars are here. Waymo have cars running in Arizona today that are fully autonomous. That the general public can. I mean, maybe it's a limited number of people, or maybe it's a limited kind of zone. But maybe I should back up a bit for those unfamiliar with the like levels of autonomy. Basically, you go from kind of a scale where level 1, I'm not even sure what level 1 is. Level 2 is that the car can kind of like do basic things. So this is kind of like a Tesla autopilot, where it can, the car can steer in a lane, and the car can brake and accelerate for you. But ultimately, at level 2, you're still completely responsible for anything the car does. So if the car crashes, you can't kind of blame it on the car. Level 3 is basically that in some situations, the car can be fully responsible, but it may need to wake you up. So like you can go to sleep, maybe it'll put you on the freeway, and maybe it'll do the bulk of the driving. But you're going to get like a 30-second warning or something saying like, hey, by the way, it's time to wake up because I don't know what I'm doing. I need help. But there's some kind of warning element. Whereas level 2, it's like, I don't know, the car might just do something crazy. And then the definition of level 4 is that within a defined kind of operating domain, the car can be fully responsible. And so that's, where you see the companies doing robotaxis. The cars are fully responsible in that you jump in the taxi, it takes you from A to B, and you jump out and you're done. There's a geofence around it. You can't, jump in it and expect you to drive it to your next state, or in some cases it can't even, drive on the freeway. But within the domain it was designed for, the car is completely responsible. And
that might be like not some level of highway or something. Right. It's like a restriction on where it can go.
The domain could be restricted to certain roads. It could be restricted to a certain time of day, like night and day.
And weather
it could be
conditions.
restricted to weather conditions. Yeah, if there's heavy rain, they're going to pull them off the road. But in the operating domain that it was designed for, the car is fully responsible. And so that is happening today, right? And that, that is, I think, it's just going to be something. It'll be over the next 10 years. It's just going to increase. Right? There'll be more and more domains where you can see it. More and more, companies are going to be deploying cars out there. More domains are opening up. Certainly, I think we'll see this happening in San Francisco very soon, probably, on the order of like next year or the year after, or
really, that's
maybe
awesome.
the year after that. But I think that, and again, in certain domains, right? Maybe if it starts raining, which doesn't really happen very often in San Francisco, but maybe if that does, then the cars aren't going to be running. I don't know. But I think, like I said, they're already doing this in Arizona. I think it's only a matter of time until you start seeing it in denser cities. And then it just evolves from there, right? The kind of domain expands, and eventually the cars have better sensors and more processing power and can go faster, more safely. And so that I think is just going to be, very like smooth and iterative. But the, level 5, I think is kind of, in my opinion, not even really worth defining. Level 5 is kind of defined as like the car can do everything a human can do. And in my mind, I'm not clear why you would really want a car to do that. I guess like there's expanding level 4 to like, hey, it can drive on every open road and
during
like,
all weather
in the country
conditions.
or the world, right? Mm-hmm. But like everything a human can drive like a 4-wheel drive through a burning forest, avoiding flames, and like humans are very adaptive in the right situation, right? And I don't know that I ever see a world where a car is going to be able to do literally everything a human can do. But it doesn't matter, right? You're going to get to a point where a car can drive you, from one side of the country to the other without stopping and without you. Without even having a steering wheel, then it doesn't really matter that it can't drive through a burning forest or something.
Yep. Gotcha. Yeah. Well, that's awesome. It's so interesting that it's so close. I look forward to. I hope in like a year or two, I'm able to take a ride in San Francisco.
Yeah, I mean, these things start slowly, right? It's like Uber existed in 2010, but no one was using it until later. Or, it takes the company, they onboard people and they have to ramp up their operations and they have to improve. Every year the cars get better. They're able to handle more situations. They're more assertive. They're more human-like in their driving. It's only a matter of time until the areas that they can operate effectively kind of increases. But you might have to get on a waiting list or something.
Yep. Let's see. And so starting to wrap up, what advice do you have for someone that's just starting their career or think like really early, like a 20-year-old you? What would the advice, and for now, what advice would you have? I
think, robotics is a big space, and figure out which pieces that you're interested in. And, a couple of things. One, maybe don't get too bogged down in thinking that you need to like specifically work on ML or something, or, you can be an electrical engineer working in robotics, or, things like that.
That's what I am.
Yeah, well, there you go. So don't rule that out, right? There's a lot of there's robotics industry is very diverse in terms of skill sets, and it takes all of those different skill sets to come together. It's not just a bunch of ML engineers or robotics engineers writing C++. And so I think don't certainly like take classes or try and get internships at different companies and work on different things. But don't get hung up on this feeling that you need one specific kind of skill set to get into robotics. I think everyone can get into robotics if you're sufficiently interested. And then the other thing is just, I think generally people early in their career vastly underestimate how valuable it can be to build hobby projects where you control end to end. And this is not like I'm not saying like go and do work in your spare time or something. But if you want to understand how robots work, go and get, you can get a kit for under $100 off Amazon to build a self-driving car with just, some little motors and a little camera, a little Raspberry Pi camera and things. But build the end-to-end thing, right? I mean, there's stuff out there even like Ducky Town, which is great, but even that is coming to you with a lot of pieces already thought out. And if you're forced to just kind of like build a little hobby project where you even just get like a Raspberry Pi and install Python on it and figure out how to control the little servos from your command line, you don't even have to have any like sensing or thinking or acting happening. Just like just figure out how to like get command line happening wired up through to your Python and make the wheels spin. That'll teach you a lot about how the end-to-end piece works. And when you go into a company, sure, it's not going to be like directly applicable, but you understand how the kind of how the pieces fit in. And I think that engineers that I've worked with that can kind of go from like the very big to the very small and back again are the best in the industry. The ones that are not just thinking about, what is this little component that I'm working on, but how does it fit into the bigger picture? And obviously at a big company, no one human can understand the big picture. So doing that on a much smaller scale is just really important to understand, like what all of those components actually look like.
Mm-hmm. So now, how can people reach out, or how can they contribute to Foxglove? Any links or anything you'd like to share?
Definitely, yeah. We love contributions. We love people reaching out. We have, so you can go to foxglove.dev. That's our website. You can download Foxglove Studio. You can open it in the browser, try it out, give us feedback. We have links on there to our community channels, GitHub, Slack, things like that. If you find that useful, great. Tell us. We love feedback. Feel free to make contributions, pull requests, report issues. Those are all helpful. Also, if this is something that's interesting to you, if there's something you want to work on, just feel free to, contact me or us directly. And if it's something that you're working on at a company and feel like you are struggling with these kind of tools around how you're collaborating over robotics data, also reach out. We'd love to chat about it, even if that's kind of getting you access to our beta or just talking a bit more about where we're going. We're an early stage company. We love getting feedback from people and just engaging with the community. So.
All right. Awesome. Thank you.
Awesome. Thanks, Audrow.
That's all we have for you today. I was surprised by Adrian's answer to what he thinks for the timeline of autonomous cars. What do you think? Let us know in the comments on sensethinkact.com. Thank you again to our founding sponsor, Open Robotics. Goodbye, everyone.